The video showcases how easy to implement a system integration scenario with the Alex Connect product. Organizations usually have an infrastructure comprising multiple systems that communicate via various protocols. Introducing new flows and communications within such an infrastructure can become a hard problem to solve, but it can become a trivial one with Alex Connect. Let's consider a legacy customer relationship management system that implements some very basic CRM features. In the existing setup, it receives new customer tickets via REST API, saves it to an internal database, and then processes it according to business workflows. The business requests some modern features to be added to the ticket processing flow, like send a confirmation notification to a customer, indicating the ticket was accepted, or integrate the CRM data to centralized storage of a brand new ERP system. The new features obviously must not break the legacy CRM flow. Here's the new ticket processing flow. The HTTP load balancer is reconfigured to forward REST requests to Alex Connect instead of the legacy CRM. Alex will forward it to the legacy CRM. Then it will send a notification to the customer using SMPP protocol and then push the ticket data to a Kafka topic. The ERP system will consume the data from Kafka. We will use Alex Connect and the Eclipse-based UI that facilitates easy system integration. It provides a big library of well-tested, highly reliable, and reusable connectors. Those connectors have been successfully used in many service-critical deployments, including the telecom domain. Some connectors provide file-based integration for different file formats. There are connectors for HTTP-based interfaces, such as REST and SOAP, connectors for message queues integration, such as Kafka, and many more. New protocol support can be added easily. We're going to use a few of them for the CRM integration scenario. We create a new flow describing the integration. Note that connectors are also called resource adapters in Alex. We're going to use the HTTP server connector to accept the REST requests. The tickets data will be pushed to ERP via Kafka connector. The producer mode should be configured, providing relevant topic information so that the ERP consumers could read it. The flow will send customer notifications using SMS-C via the SMPP connector. The HTTP client connector will be used for the legacy CRM integration. The flow can also be documented in a sequence diagram format, visualizing the agents and how they communicate. Now we're going to implement the required flow logic with an Alex state machine. A state machine consists of states, transitions, and chains of actions fulfilling the data transformations as required. The flow starts with awaiting an incoming REST request. This is the initial state. Now we're going to specify how to handle the request, adding a chain of actions. An action in Alex is an isolated, reusable block that can perform one small task very well. There's a decent library of actions in Alex. They're grouped by topic. For example, there's a subset of actions for arrays manipulations or different data encoding, decoding transformations. Another group of actions facilitates basic math operations. There's a group of actions to manipulate with strings, from simple concatenation to complex regular expressions. The type conversions group allows data formats translation across different systems. We need to save the incoming request first so that the state machine could manipulate with its data. So we're choosing the Save Message action. We have to specify where to keep the request data. Name this piece of data CRM request. Now we indicate that the waiting state should proceed with the chain execution upon HTTP indication arrival. The state machine data is stored in so-called variables. They're named pieces of data each action of this state machine can access. The incoming request brings 3 fields in its JSON body: the customer name, the mobile number, and the ticket text. At first, we're going to forward the request to the legacy CRM system using the send message action. Note that its appearance differs from the other action types. It does not require any transformations, so just pass the CRM request data transparently by choosing a respective variable. Each action can fail or succeed. Now we're going to draw the positive path and get back to the negative scenarios later. The state machine should await for the CRM system response. If it doesn't arrive in 10 seconds, we should apply a timeout handling. For example, retry after a while. At the next step, we're going to prepare a notification in the SMPP protocol format and send it via SMS Center. It can be accomplished with a protocol mapping block. A protocol mapping is a special type of block combining multiple steps in one place. There are templates for each protocol format in the Alex library, so we just choose an appropriate one and set the rules on how to fill the SMPP payload. We're going to use the ticket data kept in the state machine variables. The mandatory fields to fill are the destination mobile number and the short message text. Optionally, we can indicate whether a delivery status is required, or set the sender's name that will be displayed at the customer's handset. Again, Alex Connect provides a lot of flexibility to apply whatever negative handling is required. In this case, we're going to set a retry for both SMSC delivery failure and the 5-second timeout. After a successful notification delivery, the ticket data should be published to Kafka message queue to be consumed by ERP. The data should be encoded in the CSV format, and there's a respective template in Alex for that. Protocol mapping can also apply transformations to particular fields. For example, we know that ERP expects the mobile number in 10-digit format. So we're going to extract these 10 digits with the getSubstring action, specifying proper parameters. The substring position is 2, and the substring length is 10. Possible Kafka producer failures can be handled with an arbitrary chain of actions, same as for other connections. All the steps of the flow have been completed successfully, so let's send a REST API response to the front end using the send message action. The send message action pushes the response to the HTTP connector. Then we're going to end the positive scenario path with a proper log message and a special close session action that ends the flow. Let's get back to the handling of the negative scenarios as promised. We can either prepare special handling for each failed action, or we can introduce a single exit point for all internal failures. For the latter case, we're going to enable a default bad result handler. We create a handler, set its entry action, which is the log action in this case, and then route all the bad transitions there in a few clicks. The prepared flow can be automatically deployed to the Alex cluster. It is linearly scalable, covering as much traffic as required. Alex Connect provides various traffic counters and alarms that enable system monitoring in real time. It follows the best operation and maintenance practices. Alex Connect enables very fast system integration using a production-proven library of connectors and a drag-and-drop flow editor. It was implemented with high performance and high reliability in mind and requires no programming skills. Thanks for watching, and find more information at dstreams.ai.